Something is breaking apart beneath the Pacific Ocean, and scientists have now captured something they have never been able to see before, a tectonic plate actually tearing itself apart beneath the seafloor off the coast of Vancouver Island. This isn't a prediction. It isn't a computer simulation. Scientists used seismic imaging to reveal enormous fractures cutting through the plate, including one section that has dropped roughly 5 kilometers relative to the rock beside it. But here's the part that makes this discovery so important. The same region has recently been hit by a cluster of powerful earthquakes. So what exactly is happening beneath the Pacific Northwest? And more importantly, does a tectonic plate breaking apart off the US coast have anything to do with the Cascadia Big One that scientists have warned about for decades? The answer is not what you might expect. Because what researchers discovered isn't simply a plate cracking. They may have captured the final stages of a subduction zone dying, a process scientists have theorized about for decades, but had never actually been able to see this clearly. And what happens next could change how scientists understand this entire region. Let's start with what they found. Because this is a genuinely landmark discovery in geology, not just a dramatic headline attached to routine research. Published in the journal Science Advances, led by geophysicist Brandon Schuck at Louisiana State University, alongside researchers from Columbia University's Lamont Doherty Earth Observatory, this study captured, for the first time in the history of geology, direct, high-resolution images of a subduction zone in the actual process of dying. Not eroding gradually, over an unobservable span of geologic time in a way scientists could only theorize about. Actually breaking, in real, current physical detail, off the coast of a US state. Here's the setting. Off Vancouver Island, in a stretch of ocean floor called the Cascadia region, 2 tectonic plates, the Juan de Fuca Plate and a smaller neighboring plate called the Explorer Plate, have been slowly sliding beneath the much larger North American plate for millions of years, in the same basic subduction process responsible for the broader Cascadia hazard zone running from Northern California up through Washington and into Canada. What researchers found is that this system isn't behaving as one smooth, continuous slab quietly diving underneath the continent. It's actively tearing itself into fragments as it goes. The team used a technique called seismic reflection imaging, which works essentially like an ultrasound of the Earth's interior. During a research expedition called the Cascadia Seismic Imaging Experiment, conducted aboard Lamont Doherty's research vessel, the Marcus G. Langseth, scientists sent sound waves down into the seafloor and recorded the echoes using a 15-kilometer-long streamer of underwater listening devices trailing behind the ship. Combined with detailed earthquake records collected over years, that imaging revealed something genuinely unprecedented. Large tears slicing directly through the descending Juan de Fuca Plate, including one massive break where the slab has physically dropped by roughly 5 kilometers relative to the section next to it. Lead researcher Brandon Schuck described it directly. There's a very large fault actively breaking the subducting plate, caught in real time, in a way nobody had ever clearly documented before. I want to explain why this discovery matters scientifically beyond just being a striking image, because it answers a genuinely long-standing question in geology. Subduction zones, the places where one tectonic plate dives beneath another, don't last forever. If they did, continents would endlessly collide and stack on top of each other, eventually erasing oceans and wiping out the geological record of Earth's past. Scientists have long known that subduction zones eventually shut down, but the actual mechanism, exactly how a massive, active geological system like this one finally grinds to a halt, had never been directly observed and documented with this level of clarity. Lamont Doherty scientist Suzanne Carbot, a co-author on the study, put it plainly: researchers have known for decades that subduction can stall when lighter, more buoyant sections of a plate arrive at the boundary and essentially resist being pulled under. But there had never previously been such a clear, direct picture of that process actually happening. Here's the metaphor Schuck used that I think captures this whole story better than any technical description could. Getting a subduction zone started in the first place, he explained, is like trying to push a train uphill. It takes an enormous, sustained effort over millions of years. But once it's moving, it's like that same train racing downhill, essentially impossible to stop through ordinary means. Ending a subduction zone, once it's already running, requires something dramatic. In his words, basically a train wreck. And that's exactly what scientists are now watching unfold off Vancouver Island. The northern end of the Cascadia subduction zone gradually shutting down, piece by piece, small fragments of the plate breaking off entirely while the remaining connected plate continues subducting normally until the next tear occurs somewhere else along the boundary. Let me get into the specific structure of what's actually breaking apart, because this is where the getting worse part of this story genuinely connects to real, ongoing seismic activity in the exact same location. What used to function as a single, continuous oceanic plate has been sliced into 2 distinct pieces. On one side sits the larger, better-known Juan de Fuca Plate, which continues subducting at a relatively steady rate of roughly 4 centimeters per year. On the other side sits the smaller Explorer microplate, moving at a noticeably slower rate of only about 2 centimeters per year. That mismatch, one section of the original plate essentially still driving forward at full speed while the other section has begun stalling and detaching, is precisely the mechanical stress responsible for tearing the two apart. Separating them is a narrow shear zone roughly 20 kilometers wide, where a structure called the Nootka Fault zone cuts down from the seafloor deep into the upper mantle, essentially acting as the boundary where this active tearing is concentrated. Now, here's why I can honestly tell you this process is getting worse. In the sense of continuing and intensifying, without that meaning, it poses an escalating danger to anyone on land. This exact structure, the Explorer plate and the fracture zone, tearing it away from the rest of the system, has been the source of a genuine cluster of real, moderate earthquakes in recent months. 2 separate magnitude, 5.6 earthquakes struck within this same tearing structure within about 12 days of each other, both located offshore, both associated with the Explorer plate's ongoing fragmentation rather than with the deep, locked portion of the Cascadia megathrust that produces the truly catastrophic earthquakes this region is best known for. A 2025 imaging study specifically identified 2 active tears in the subducting slab in this area, along with a fault network roughly 20 kilometers wide, cutting through sediment, through crust, and down into the upper mantle. The Explorer microplate is, quite literally, in the ongoing process of being severed from the broader subduction system, and that process is actively producing real, measurable earthquakes as it continues. I want to be precise about what kind of earthquakes these actually are, because it's the single most important distinction in this entire story, and it's exactly the kind of nuance that separates an accurate, informative breakdown from a headline designed purely to alarm you. These are fracture earthquakes, produced by a plate that is actively coming apart at its own internal boundary. They are not megathrust earthquakes generated along the main, locked Cascadia interface, the specific fault capable of producing the magnitude 8 or 9 big one scenario that gets discussed whenever Pacific Northwest earthquake risk comes up. The tearing happening to the Explorer plate tells scientists that the northern end of this subduction system is disintegrating, essentially on its own separate schedule, entirely apart from the deep, locked megathrust zone running beneath Washington, Oregon, and Northern California. It tells us nothing directly about when that much larger, much more dangerous locked zone will eventually fail. That distinction matters enormously, and I want to walk through why, because it's exactly the kind of thing that gets flattened the moment a headline uses the phrase tectonic plate breaking apart off the U.S. coast without the surrounding context. The Cascadia megathrust, the fault responsible for the last truly catastrophic Pacific Northwest earthquake back on January 26, 1700, is a completely separate structure from the Explorer plate's internal tearing. Stress from a plate fracturing at its own boundary, hundreds of kilometers away from the main locked interface, doesn't mechanically transfer in any meaningful way to accelerate or delay that separate, much larger system. Treating every earthquake in this general region as evidence that the big one is getting closer is precisely the kind of oversimplified dominoes-style thinking that leads people to manufacture forecasts of imminent disaster that the actual science simply doesn't support. Let me also address the framing in this study's own coverage directly, because I think it's genuinely important and adds real, honest balance to this story. Lamont Doherty's own summary of this research carried a headline stating plainly that this discovery isn't necessarily bad news. That's not spin to soften a scary finding. It reflects the actual scientific value of what's been captured here. For the first time, researchers have a clear, detailed window into exactly how subduction zones naturally end, a process that's happened repeatedly throughout Earth's geological history and helps explain previously mysterious ancient plate fragments found elsewhere around the world. Understanding this process in unprecedented detail off a coastline where scientists already maintain dense, sophisticated monitoring, specifically because of the region's broader seismic hazard, genuinely helps refine hazard models rather than simply adding a new, undifferentiated source of fear to an already well-studied risk landscape. So let's bring this together, because I think the complete, accurate version of this story is more genuinely fascinating than either the alarming version or a dismissive one. Scientists have, for the first time in geological history, directly imaged a subduction zone in the literal act of tearing itself apart off the coast of Vancouver Island, where the Explorer microplate is actively detaching from the larger Juan de Fuca Plate, along a wide shear zone anchored by the Nootka Fault. That tearing process is real, it's ongoing, and it has been producing genuine moderate earthquakes, including a pair of magnitude 5.6 events within the same structure in recent months, which is the honest basis for describing the situation as getting worse in the sense of continuing measurable activity. What it does not represent is any kind of evidence pointing toward an accelerated timeline for the separate, deeply locked Cascadia megathrust, the fault system actually responsible for the region's catastrophic Big One earthquake risk. These are fracture earthquakes on a plate that's coming apart at its own internal boundary, mechanically distinct from the megathrust interface that remains the primary, well-documented hazard for this coastline, a hazard that exists and gets monitored closely, entirely independent of whether the Explorer plate happens to be tearing further apart in any given month. Here's the practical takeaway, and I think it's genuinely useful for anyone living along the Pacific Northwest coast. This discovery doesn't change anything about the standing, well-established earthquake and tsunami preparedness advice that's applied to this region for years. Know your evacuation route if you live in a coastal tsunami zone. Understand that the Cascadia megathrust remains capable of producing a magnitude 8 or 9 earthquake at some point on a geological timescale. Nobody can currently predict with precision. And treat this new research as exactly what it is, a genuinely exciting scientific breakthrough in understanding how subduction zones naturally evolve and end, not a new, escalating threat requiring any change to your existing preparedness. I want to close with the honest uncertainty here, because that's always the right way to end a story built on cutting-edge, recently published research rather than decades-old, thoroughly settled science. This study represents the first direct observation of this specific process anywhere on Earth, which means researchers are still actively working through exactly what it implies for long-term hazard modeling in this specific region. What it doesn't do, based on everything the data currently shows, is provide any evidence that the Explorer plate's tearing accelerates, delays, or otherwise meaningfully interacts with the separate, locked Cascadia interface responsible for this region's most catastrophic earthquake risk. Before you go, I want to ask you something, because I think this story is a genuinely good example of how a scientifically exciting discovery and a scary-sounding headline can describe the exact same research completely differently. Does hearing a tectonic plate off the US coast is breaking apart make this sound more alarming to you than the actual complete explanation that scientists have captured a natural, well-understood geological process in unprecedented detail, mechanically separate from the region's main earthquake hazard? Drop a comment and tell me honestly, because I think that gap between a technically accurate but incomplete headline and the full scientific picture is exactly the kind of thing worth learning to spot. If this gave you a clearer, more complete picture of what scientists actually found and what it does and doesn't mean for Pacific Northwest earthquake risk, hit that like button, because it genuinely helps careful, well-sourced breakdowns like this one reach people instead of the version that stops at the scary headline. Subscribe to Nomura Proof so you're here for the next update on Cascadia, the Explorer plate, or any other seismic research coming out of this region, because I'll keep giving you the real science behind every headline. Drop your thoughts in the comments, and I'll see you in the next one.